Other than lines and parabolas, one of the first shapes in the coordinate plane that you learn about is circles. Circles have a nice symmetry that interested mathematicians going way back to the ancient Greeks. So let's talk about circles in the coordinate plane. To describe a circle, since it's a curve, we need an equation. So let's start out by trying to find the equation of a circle. Let's write the equation of a circle with center at 2, -1 and radius r equals 3. So let's draw a picture of this situation. The point 2, -1, let's see, that's going to be 2 in the x direction and -1 in the y direction. So there's our center. And the radius is 3, and 3 units is going to be maybe 1, 2, 3 out to here. And so our circle is going to look something like this. All of the points that are 3 units from the center. So the circle that we're talking about is all points 3 units from the center point 2, -1. So we need to somehow write an equation for this. Well, how do you do that? Generally, how you can write an equation for something is try to describe it in symbols that in a way that somehow reflects the geometric description, the words. So what we need to do is somehow describe all points that are 3 units from 2, -1. Well, describing all points is tricky. Let's describe the points one at a time. So here's one of those points, but this point really needs to represent any point on the circle, so we can't write numbers for its coordinates. Instead, let's write x, y. Because if we use variables for the coordinates of this point, it can represent any point. Remember that the center of this circle is 2, -1. So let's write down an equation that says that our point x, y is 3 units from 2, 1. So we want to write that the distance from x, y to 2, -1 equals 3. All right, well, look, we're writing an equation with a distance. That means we should use the distance formula. So we have an equation where the right-hand side is just our radius, 3, but the left-hand side is going to be the distance formula. Well, you know, the distance formula, I'll just write it quickly. It was the difference in x-coordinate squared plus the difference in y-coordinate squared. It's really kind of messy to have a square root. People don't like having square roots around if they don't need to have the square roots. And one way to get rid of the square root is just to square both sides. So before we actually write the equation, let's square both sides. On the right-hand side, we get 3 squared, which is 9. Remember, this 9 is really just the radius squared. And then on the left-hand side, we'll write the difference in x-coordinates. And remember, we're looking at the x-coordinates of our 2 points here. So the difference in x-coordinates is x minus 2. So that's squared, plus the difference in y-coordinates squared. And the y-coordinates are y and -1. So y minus -1. And then if you want to, you can simplify this a little bit. X minus 2 squared plus y plus 1 squared equals 9. So there's the equation of our circle. If you did multiply out these squarings, it would change how the equation looks, but it wouldn't really change what the equation says. And leaving it this way, not multiplied out, is kind of nice because the coordinates for the center of the circle are right here. The x-coordinate for the center is 2, and the y-coordinate is -1. You have to be kind of careful about the plus or the minus there. And also the radius for the circle is just the square root of the number that shows up on the right-hand side. Okay? So writing the equation of a circle this way is actually pretty nice because the center and the radius of the circle are staring you right in the face. If you multiplied this equation out, you wouldn't have the center and the radius staring you in the face anymore. In fact, the fact that the center and the radius show up in the equation of the circle makes the equation of any circle easy to write down. So let's say that the center of our circle was h comma k and the radius was r. We could play the same game of having a point, or we're going to write the equation of the circle with radius r and center h comma k. Well, we can play the same game with calling a point on the circle x comma y and then just write down delta x squared plus delta y squared equals the radius squared, just like before. Well, this time delta x is x minus the x-coordinate of the center, so x minus the x-coordinate of the center, so x minus h squared, plus, and then for y-coordinates, the y-coordinate of our point minus the y-coordinate of the center, so y minus k squared, and then on the right-hand side, r squared. So you can see, just like in the example where we actually had some numbers, the center of the circle and the radius of the circle show up in the equation. So that means you can always write the equation of any circle if you have a geometric description of the circle. If you have a circle with center hk and radius r, the equation for that circle is x minus h squared plus y minus k squared equals r squared. Nice. Of course, if you do have an equation that might be a circle, but it's all multiplied out, how could you just figure out what circle that is? So let's find what circle has equation x squared plus 6x plus y squared minus 8y equals 11. Well, if you remember the general equation of the circle that we had written down a second ago, that was x minus h squared plus y minus k squared equals r squared. This general equation for the circle, it has x, it doesn't have x showing up more than once, right? Our equation has x showing up in a squared term, but also in an x term. But we want an equation that has a squared term that has x plus or minus something. And then the same thing happens for y. We have y showing up twice, but we want y to only show up once. So how is it that we could take these two terms that have x and turn them into one term that's squared with x in it? Well, there is an algebraic trick for that you might remember, and it's called completing the square. So the trick for completing the square is we're going to take this coefficient on our x term. I should say this trick for completing the square only works if the coefficient on your squared term is 1. And for us it is, because it's just x squared by itself. That means it's 1 times x squared. So since we have this 1 by itself, we can do this trick for completing the square. Take the coefficient on the x term, that's 6, divide that by 2, that's 3, and then take the result and square it, and that's 9. That means that for the x's, the missing part of the square is 9. So we're going to add 9 to both sides of the equation. Well, we also need to find the missing part of the square for y. So looking at our y's, on the squared term, the coefficient is 1, and that means we can do the same trick. Take the coefficient on y, which is minus 8, divide that by 2, that gives us minus 4, and then take the result, minus 4, and square it, and that gives us 16. That means the missing part of the square for the y's is 16. So we'll add 16 to both sides of the equation. All right, so on the left-hand side of the equation, for the x's, we have x squared plus 6x plus 9. And then for the y's, we have plus y squared minus 8y plus 16. And then on the right-hand side, we have 11 plus 9 plus 16. So 11 plus 9 is 20, plus 9 is 36. All right, so the equation that we started with turns into this big mess. And this looks worse at first, but look at these first three pieces. Can you factor that? That does factor. In fact, it's a perfect square. These first three terms with our x's are x plus 3. Take a second to check that. So x plus 3 squared, that would be x times x is x squared. X plus 3 is 3x. 3 times x is another 3x, so that's 6x total. And 3 times 3 is 9. Okay, so the first three terms are x plus 3 squared. Now let's look at the y terms. Well, you probably would guess that these are going to factor, and they do. These y terms are the square of y minus 4. And again, check that. Y times y is y squared. Y times minus 4 is minus 4y. Minus 4 times y is minus 4y. So together that's minus 8y total. And then minus 4 times minus 4 is plus 16. And the right-hand side is 36. Now this process of completing the square has turned our equation into exactly the kind of equation where we know what the circle is. So if you compare the equation we have to this equation way up here that we were hoping to get, it looks almost the same. Really, the only difference is we needed a minus, but in our x's we have a plus. But we can fix that because plus 3 is the same thing as minus negative 3. So x minus negative 3 squared plus y minus 4 squared equals 36. All right. Now that we have the equation for the circle written this way, we can identify the center of the circle and the radius of the circle. So remember, h, the x-coordinate of the center of the circle, shows up subtracting x here. So for this circle, h is minus 3. K, the y-coordinate of the center of the circle, shows up subtracting y right there. And so for our circle, the y-coordinate of the center of the circle is 4. And then the radius is the square root of the number on the right-hand side, and that's 6. So the equation that we started with is actually the circle centered at minus 3, 4 with radius 6.